Hi students, today we are going to discuss Bose Einstein gas. Bose Einstein gas means nothing but it is an assembly of bosons. We know that bosons have either zero or integral spin, that is integral spin means 1, 2, 3 etc. Then bosons have spin 0, 1, 2, 3 etc. That we can write it as S is equal to 0, 1, 2, 3 etc. in case of bosons. If we consider an ideal Bose gas, this means that the particles are non-interacting. That is, there is no mutual interaction between the particles, so that potential energy of interaction is 0 and hence the energy is entirely kinetic. That means it is translation in character and hence we can represent its energy as epsilon is equal to p square by 2m. Now let us consider an assembly of n boson and it is distributed as n1, n2, n3 etc. in the energy levels E1, E2, E3 etc. up to Ei. This is up to Ni, N1, N2, N3 etc. to Ni in the energy levels E1, E2, E3 etc. having degeneracies G1, G2, G3 etc. up to Ga respectively. Then from the context of Bose Einstein distribution statistics, we can write Ni as, that is the most probable distribution will be given by the equation Ni is equal to Gi divided by e raised to alpha plus beta epsilon I minus 1. Then as a next step we can substitute e raised to minus alpha as A. Thus for Ni equation we can write Gi divided by e raised to 1 by e raised to minus alpha into e raised to beta epsilon I minus 1. And that is Ni is equal to Gi divided by 1 by e raised to minus alpha means 1 by A into e raised to beta epsilon I minus 1. Here Ni is the number of particles and it cannot be negative. It will be either 0 or positive. And Gi is degeneracy and then it is also positive. Then this Ni and Gi will be positive. Hence we can write this term will be also positive. That is, that will be greater than or equal to 0. 1 in the left hand side can move to the right. Then we can write the equation as 1 by A into e raised to beta epsilon I greater than or equal to 1. If the lowest energy level is the ground state energy level and it is taken as 0, then we can write epsilon I is equal to 0. Epsilon I is equal to 0 means e raised to beta epsilon I equal to 1. That is e raised to 0 equal to 1. Then the above equation, that is this equation we can be written as 1 by A into 1, that is e raised to beta epsilon I is equal to 1, that is 1 by A greater than or equal to 1, that is A will be less than or equal to 1. Here a is nothing but a is e raised to minus alpha. A is e raised to minus alpha. If we examine the value of e raised to alpha, we can write a is equal to 1 by e raised to alpha, that is equal to 1 by 2 raised to 7, approximately the value of e, that is 2.7 raised to alpha. That means a is always positive. This equation implies that a is always positive. Or we can go through the graph of e raised to minus alpha for either the value of alpha, e raised to minus alpha is positive. And hence we can say that a is always greater than or equal to 0. Hence we can write, now we can get that a less than or equal to 1 and a greater than or equal to 0. Hence the value of a lies in between 0 and 1, that is 0 less than or equal to a less than or equal to 1. Hence this is the value of a which lies in between 0 and 1. And alpha means nothing but it is minus mu by kT. Mu is chemical potential. Chemical potential. Since the value of a is in between 0 and 1, alpha should be greater than or equal to 0. Hence, alpha should be greater than or equal to 0. And we know that alpha is equal to minus mu by kT. Therefore, for alpha become positive, mu must be negative. Then mu less than or equal to 0. Now we have to find out the total number of particles n. For that we have to find out n, that can be represented as integral dn, and that is equal to integral n epsilon d epsilon. That is total number of particles n is equal to integral n epsilon d epsilon. Then we can represent dn is equal to n epsilon d epsilon, and also we can write Bose Einstein distribution function is equal to f of epsilon is equal to n epsilon by g epsilon. From this equation we can write n epsilon is equal to f of epsilon g epsilon, and we have to find out g epsilon d epsilon. For that, first of all we have to find out gp dp, and it is given by the equation gs into triple integral dx dy dz into triple integral dpx dpy dpz divided by h cube. Here gs is nothing but it is the spin degeneracy, and it can be written as gs is equal to 2s plus 1, and when s is equal to 0, gs will be equal to 1, and hence gp dp we can be write gp dp as gs into, that is 1 into triple integral over position coordinate, that is dx dy dz, that can be represented as, this term can be represented as v into triple integral dpx dpy dpz, that is the momentum coordinates in the phase space, the momentum coordinates in which we consider in the phase space divided by h cube. Hence the expression for gp dp becomes gs into v into 4 pi p square. Here triple integral over dpx dpy dpz, that is 4 pi p square dp. In order to find out the triple integral dpx dpy dpz, the small elementary volume, we have to consider a sphere having thickness dp, radius p and thickness dp. Hence the elementary volume will become 4 pi p square dp, that is integral triple integral dpx dpy dpz is equal to 4 pi p square into dp. Hence the expression for Gp dP becomes Gs into V into 4 pi p square dP divided by h cube. When s is equal to 0, Gs equal to 1, then the equation reduces to Gp dP is equal to V into 4 pi p square dP divided by h cube. Also, we know the relation between the epsilon, the energy, and the momentum, that is epsilon is equal to p square by 2m. From this relation we can obtain p square is equal to 2m epsilon. Therefore, 2p dp will become 2p, on differentiating p square we get 2p dp, and 2m epsilon will become 2m, the constant remaining like that, and epsilon derivative will become d epsilon. Then 2p dp is equal to 2m d epsilon, and from the above expression we can obtain p dp is equal to m d epsilon. Therefore, dp can be written as m by p into d epsilon, that is equal to m by, here we know that p square is equal to 2m epsilon. Therefore, p is equal to root p is equal to root of 2m epsilon. On substituting this value we can obtain dp is equal to m divided by root of 2m epsilon into d epsilon. Therefore, g epsilon d epsilon will become, on substituting the value of epsilon in the equation, the Gp dp will become g epsilon d epsilon, and the equation will be reduces in the form V into the corresponding equation. We just only substituting the value of epsilon, the 4 pi p square dp. 4 pi p square, the equation is V into 4 pi p square dp by h cube. V as it is, 4 pi by h cube as it is, and p substitute for p square 2m epsilon, and dp it is m by root of 2m epsilon into d epsilon. On substituting these values, the equation will be reduces to g epsilon d epsilon is equal to V into 4 pi by h cube 2m epsilon into m divided by root of 2m epsilon d epsilon. Therefore, g epsilon d epsilon is equal to, on rearranging these equations we can obtain the relation as 2 pi v, just we rearrange like this, 2 pi v into 2m by h square, the whole raised to 3 by 2 into epsilon raised to half d epsilon. These two expressions are same, we just rearrange the expression like this for the simplicity. 2 pi v into 2m by h square, the whole raised to 3 by 2 into epsilon raised to half d epsilon. G epsilon d epsilon can be taken as the expression 1. Now we substitute for the equation n is equal to integral n epsilon d epsilon. Substitute in terms of f epsilon, we can obtain integral f epsilon g epsilon d epsilon. Since f epsilon is equal to n epsilon divided by g epsilon, and also the Bose Einstein distribution function f epsilon is equal to 1 by e raised to alpha plus beta epsilon minus 1. On substituting these values of f epsilon and g epsilon and d epsilon, g epsilon d epsilon, on substituting these values we can obtain n is equal to integral 1 by e raised to alpha plus beta epsilon minus 1 into 2 pi v into 2m by h square, the whole raised to 3 by 2 into epsilon raised to half d epsilon. Now substitute beta epsilon is equal to x, then we can obtain x is equal to epsilon by kt. Then epsilon is equal to x kt, then d epsilon will be obtained as kt dx, kt into dx. On substituting these values in the equation for n, we can obtain integral 1 by e raised to alpha plus x minus 1, because beta epsilon is equal to x, into 2 pi v into 2m by h square, the whole raised to 3 by 2 into x raised to half kt raised to half kt into dx. Then we can obtain this relation as n is equal to this relation. After that we rearrange the equation as v by h cube into 2 pi m kt the whole raised to 3 by 2 into 2 by root pi integral 0 to infinity x raised to half e raised to alpha plus x minus 1 into dx. Just taken the constant parts taken outside that of integral and write 2 by root pi into integral 0 to infinity x raised to half by e raised to alpha plus x minus 1 into dx. And this part of can be represented as f1 of alpha. Hence, our n is v by h cube 2 pi m kt the whole raised to 3 by 2 into f1 of alpha. Here f1 of alpha is nothing but it is 2 by root pi integral 0 to infinity x raised to half e raised to alpha plus x minus 1 into dx. Now, we have to evaluate f1 of alpha. f1 of alpha is nothing but it is 2 by root pi integral 0 to infinity x raised to half divided by 1 by a into e raised to x minus 1 dx. We know that e raised to alpha plus x we can write e raised to alpha plus x we can write it as e raised to alpha into e raised to x, that is 1 by e raised to minus alpha into e raised to x. 1 by e raised to minus alpha can be written as 1 by a into e raised to x. Hence, e raised to alpha plus x can be written as 1 by a into e raised to x. Now, in the second step, we can write cross multiply with a, we can write in this expression. In this expression, we can cross multiply with a, we can write e raised to x minus a divided by a, and we can rearrange as a into numerator, then the expression will change into the form 2 by root pi integral 0 to infinity a x raised to half divided by e raised to x minus a into dx. In the next step, take e raised to x common and outside of that relation, and we can obtain the relation as 2 by root pi integral 0 to infinity a x raised to half divided by e raised to x is common. Then the first term become 1 minus a e raised to minus x. When we take outside e raised to x from the second term, here we can get another e raised to minus x, and hence the expression reduces in the form 2 by root pi integral 0 to infinity a x raised to half divided by e raised to x into 1 minus a e raised to minus x dx. Then it can be expressed as 2 by root pi integral 0 to infinity a e raised to minus x. This e raised to x into numerator, we can obtain e raised to minus x into x raised to half into this term into numerator 1 minus a e raised to minus x the whole raised to minus 1 into dx. In the next step, we can use series expansion to this term. Then the equation will become 2 by root pi integral 0 to infinity a e raised to minus x x raised to half. Then the expansion of 1 minus a e raised to minus x the whole raised to minus 1, that is 1 plus a e raised to minus x plus a square e raised to minus 2x plus a cube e raised to minus 3x plus etc. into dx. Then we are opening the integrals with each term, then the relation becomes 2 by root pi integral 0 to infinity a e raised to minus x x raised to half dx plus 2 by root pi integral 0 to infinity a square into e raised to minus 2x x raised to half dx plus 2 by root pi integral 0 to infinity a cube e raised to minus 3x x raised to half dx plus etc. We have to evaluate these integrals using this standard result. The integration results are integral 0 to infinity e raised to minus x x raised to n minus 1 into dx can be written as gamma of n. Next relation, gamma of n plus 1 is n gamma n. Gamma of half is nothing but it is root pi. These are the relations. We can use this relation to find out the integration results. We can evaluate the first term as an example, then we can directly go to the result. Integral 0 to infinity e raised to minus x raised to half dx, that can be rearranged into the standard form as integral 0 to infinity e raised to minus x raised to half. X raised to half can be rewritten as x raised to 3 by 2 minus 1, that is also x raised to half into dx. Then it is in the form of this equation e raised to minus x raised to n minus 1 into dx. Then its result is gamma of n, that is gamma of 3 by 2. Here 3 by 2 is n, here gamma is 3 by 2. It can be represented as root of gamma of 1 by gamma of 3 by 2, that can be represented as gamma of 1 by 2 plus 1. Gamma of n plus 1 is nothing but n gamma n, that is gamma of 1 by 2 plus 1 can be written as 1 by 2 gamma 1 by 2, and gamma of 1 by 2 is nothing but it is root pi. Then we can write 1 by 2 root pi is root pi by 2, that is the first result. Similarly, we can find each term and the standard result will become a plus a square by 2 raised to 3 by 2 plus a cube by 3 raised to 3 by 2 plus etc. and plus etc. And this can be written in terms of summation series, that is equal to summation over n equal to 1 to infinity a raised to r divided by r raised to 3 by 2. We know the value of n as v by h cube into 2 pi m kt the whole raised to 3 by 2 into f1 of alpha, that is equal to v by h cube into 2 pi m kt the whole raised to 3 by 2 into f1 of alpha is nothing but it is summation over n equal to 1 to infinity a raised to r divided by r raised to 3 by 2. This is our equation number 2. Please remember this equation also. Now we have to find out total energy of the system, and it is obtained by the relation integral 0 to infinity epsilon n epsilon d epsilon. Here also we want to substitute epsilon by kt is equal to x and epsilon is equal to x kt. Then substitute the value of epsilon is equal to x kt and also multiplying and dividing by 3 by 2. Then we can obtain the relation as 3 by 2 into v by h cube 2 pi m kt the whole raised 3 by 2 into 2 by 3 into 2 by root pi integral 0 to infinity x kt x raised to half dx divided by e raised to alpha plus x minus 1, that is equal to 3 by 2 kt. This equation can be rearranged. This kt is taken here, 3 by 2 kt into the constant term v by h cube into 2 pi m kt the whole raised to 3 by 2 into this 4 by 3 root pi into integral 0 to x raised to half into x, that is x raised to 3 by 2 divided by e raised to alpha plus x minus 1 into dx, that is equal to 3 by 2 kt into v by h cube 2 pi m kt the whole raised to 3 by 2 f2 of alpha. Here this term is taken as f2 of alpha, that is 4 by 3 root pi into integral 0 to infinity x raised to 3 by 2 divided by e raised to alpha plus x minus 1 into dx. Here f2 of alpha is 4 by 3 root pi integral 0 to infinity x raised to 3 by 2 divided by e raised to alpha plus x minus 1 into dx. Similar to f1 of alpha, f2 of alpha is also find out using standard integration result as a plus a square divided by 2 raised to 5 by 2 plus a cube divided by 3 raised to 5 by 2 plus etc., that is equal to summation over r is equal to 1 to infinity a raised to r divided by r raised to 5 by 2. Now we have to find out the energy density, value of energy density, that is E by n, and it is equal to the value of E by E. There is the relation 3 by 2 kt into constant term v by h cube into v by h cube into 2 pi m kt the whole raised to 3 by 2. This term also in both the terms E and N, and hence they are cancelled each other, and hence the remaining part is F1 of alpha divided by F1 of alpha in the terms of N. F1 of alpha come in the term of N, and then our expression is 3 by 2 kt into F2 of alpha divided by F2 of alpha in the expression for E, and F2 of alpha divided by F1 of alpha. F2 of alpha is nothing but it is a plus a square by 2 raised to 5 by 2 plus a cube by 3 raised to 5 by 2 plus etc. And F1 of alpha can be written as a plus a square by 2 raised to 3 by 2 plus a cube by 3 raised to 3 by 2 plus etc. the whole raised to minus 1. And from the both the terms we can take a outside. In the first term we can take a outside, and in the second term we can take a raised to minus 1 outside, and the expression become 3 by 2 kt into a raised to minus 1 into 1 plus a by 2 raised to 5 by 2 plus a square by 3 raised to 5 by 2 plus etc. and 1 plus a by 2 raised to 3 by 2 plus a square by 3 raised to 3 by 2 plus etc. And on solving this relation we can write, or using the series expansion we can write on first term as such: a raised to minus 1 is 1, and remaining term 3 by 2 kt into 1 plus a by 2 raised to 5 by 2 plus a square by 3 raised to 5 by 2 plus etc. plus next term using the series expansion 1 plus x the whole raised to minus 1 form, we can write the relation as 1 minus a by 2 raised to 3 by 2 minus a square by 3 raised to 3 by 2 minus etc. When we open this bracket we get 3 by 2 kt into 1 minus a by 2 raised to 3 by 2 plus a by 2 raised to 5 by 2. Since a is small we can neglect the higher powers of a, and also note the point that E by n is equal to 3 by 2 kt into F2 of alpha divided by F1 of alpha. For a is very less than 1, Ni is equal to Gi divided by e raised to alpha plus beta epsilon minus 1. Implies for a is very less than 1, Ni is equal to Gi divided by e raised to alpha plus beta epsilon, and it is Maxwell-Boltzmann distribution. And according to Maxwell-Boltzmann statistics we can also know here F2 of alpha for a is very less than 1, F2 of alpha divided by F1 of alpha is approximately equal to 1. From this relation, when a is very less than 1, these powers of a can be neglected. Then it is F2 of alpha by F1 of alpha can be approximated as 1, and hence E by n is equal to 3 by 2 kt. This means that, or this is well known result for a classical gas. This result is obtained because for a very less than 1 that gas can be treated by classical statistics.